Hi everyone, let's begin our look at the arguments used by flat earthers to support their absolutely ridiculous claim.
One of the most important people behind the modern flat earth movement, or whatever you want to call it, is Samuel Rowbotham, aka Parallax, 1816 to 1884, author of Zetetic Astronomy, Earth Not a Globe. A fundamentalist Christian, he found that modern astronomy contradicted the biblical description of a flat earth, and developed what he thought was a better method of investigating the universe. This method, the Zetetic method, can be summed up as: explain each individual observation in the simplest possible way which does not contradict prior knowledge. Never come up with hypotheses or theories, just make an observation and then explain it in the simplest possible manner. There's a sort of intuitive appeal to this. A simple explanation of an empirical observation, looks flat, is flat, seems like it eliminates speculation. It eliminates the need to rely on conjecture, proponents of this method say, failing to realize that when you test your explanation and find that it makes accurate predictions, it's no longer conjecture, but a conclusion based on evidence. On the other hand, when you just make up explanations without testing them and instead just assume they're correct, well,
that's the very definition of conjecture.
Clearly, this method doesn't work as a way of actually learning. In fact, the more observations you make, the worse it gets. But remember that this isn't about learning, it's all about confirming the biblical description of a flat earth.
But let's take a look at that first observation, that the Earth looks flat. Does it really? I mean, does it ever look unambiguously flat? Let's be as generous as we can and take these two questions seriously. If the Earth is a sphere, how come the horizon looks like it's at eye level? Why isn't it lower than that? And how come it looks like a straight line?
Let's put an observer on a boat. His eyes are 2 meters above the surface, and he's looking in a direction parallel with the surface of the water at his location. What will he see? Well, the horizon will appear to be at eye level, and it will appear as a line. This is not in dispute. But hang on, what is the angle between the horizon and the center of the observer's field of view? Is it really zero? Is the horizon really at eye level? Let's see what happens if we assume that the Earth is indeed a sphere with a radius of 6,400 kilometers. We start by drawing a circle and a line segment representing the height of the observer. Obviously, this figure won't be to scale, but since we won't be using it to make measurements, it won't matter. Let's draw a line straight ahead from the observer and another line from the top of the observer which is tangent to the circle, that is, a line from his eyes to the horizon. What we want to do now is calculate the angle between these two lines. Let's call it alpha. I'll add one more line straight down over here. I'll call this distance x and this distance y. The observer's height is h, the distance to the horizon is d, and the circle's radius is r. Drawing a line here, perpendicular to the radius of the circle, we find that these angles are alternate angles and thus equal. The same is true with these angles, so these triangles must be similar. Since these two triangles share this angle, and both have a right angle, it follows that they are also similar. Thus, the two original triangles are similar. This allows us to work out alpha as follows. Alpha is the sine inverse of y over d, which, since the triangles are similar, is equal to sine inverse d over h plus r. We can work out d using Pythagoras' theorem. Now we just plug in the values of h and r and we find that alpha is 0.045 degrees.
While the human eye can resolve that angle, we're not going to spot it without some kind of visual reference. And when we're just looking at the horizon, we don't have that. This problem will persist even if you're looking at the horizon from a tall building, because the angle is still going to be too small. And the same will apply if you're looking at it from most mountains. On top of Mount Everest, the horizon will be about 3 degrees below eye level.
Next, let's have our observer take a photograph using a 24mm wide-angle lens, giving him a 74-degree horizontal field of vision. What vertical angular distance should we expect between the center of the horizon and the horizon at either edge of the photo? Looking at it from above the observer, this is the distance we called x, the horizontal distance to the horizon in the first figure. That makes this distance x cosine beta, beta being half the field of view. Going back to the side view, we now draw a line segment parallel with y, x cosine beta from the observer. What we're looking for is this angle here, gamma, which is the tan inverse of y over x cosine beta. X is d cosine alpha and y is d sine alpha, so we get, well, this, which simplifies to this. Plugging in alpha from before and beta equals 37 degrees, half of 74, this comes to 0.056 degrees. So the difference between alpha and gamma is 0.011 degrees. Say that the photo has a vertical resolution of 4000 pixels. The vertical field of view is 53 degrees. That means 0.011 degrees corresponds to slightly less than 1 pixel. In other words, the curvature won't be visible in the image. What this means is that any argument about the horizon looking flat at sea level is irrelevant, as this is exactly what we would expect whether the Earth is flat or spherical with a large enough radius. For the same reason, it doesn't matter that tall buildings appear parallel. You have to be at very high altitude to see the curvature of the horizon. What you can see close to sea level, however, is the Earth curving away from you downwards. That's why there is a horizon in the first place. And that brings us to an experiment Rowbotham brought up in Zetetic Astronomy.
Yeah, hilariously, that book contains several experiments that supposedly confirm the hypothesis that the Earth is flat. Wait, I thought we shouldn't propose and test hypotheses.
Rowbotham put a telescope 20 centimeters, 8 inches, over the water of Old Bedford River, a long straight canal on the Bedford level in Norfolk, England. He calculated that if the Earth was a 6,400 kilometer radius sphere as it is described, then a horizontal distance of 8 kilometers, 5 miles, corresponds to a drop of 5 meters, 16 feet. Yet he could see a 1.5 meters, 5 feet, tall boat, all of it, at that distance. Well, here's the problem, known to land surveyors even at the time. Atmospheric refraction, something I didn't take into account in my earlier calculations. In fact, taking it into account, the Earth would look even more flat. Air density, and thus the air's refractive index, decreases with altitude. As light goes from one medium to another medium with a different refractive index, it bends toward the medium with higher index. This means that a beam of light will tend to follow the curvature of the Earth, so that objects beyond the horizon become visible. The effect can be pronounced by certain temperature conditions because cold air is denser than hot air. Suppose, for example, that you put a telescope just 20 centimeters above the surface of cold water.
Oops.
What Rowbotham saw was a superior mirage, an illusion caused by light bending down. If you have hot air near the ground instead, like above a road on a hot summer day, you get an inferior mirage, light bends up. It looks like there's water on the road, but it's actually a distorted image of what's above the horizon, typically the sky. Since flat earthers were convinced that the Bedford level was flat, that's where Alfred Russel Wallace carried out another experiment to completely blow Rowbotham's claim out of the water. Pun definitely intended, because Wallace set his sight line 4 meters above the surface rather than just 20 centimeters, thus eliminating the steep temperature gradient as a source of error. Wallace set up 3 poles in a straight line along the canal. Looking along a line from the top of the first to the top of the third through a telescope, he found that the top of the second was significantly above that line, which would be impossible on a flat Earth. The Bedford level experiments are cited all the time by flat earthers, who of course reject the outcome of Wallace's experiment because, well, you know, he obviously cheated. I mean, that's the simplest explanation that doesn't contradict what they already believe. Still, I have to grant flat earthers this much. If the horizon was visibly curved, their hypothesis would be falsified. It is a legitimate test of the hypothesis, and it does pass, so despite the fact that it's easily falsified by other observations, at least this qualifies as a valid, albeit pathetically weak, attempt to show that the Earth is flat.
That makes the arguments I've brought up here the good arguments in the Flat Earther arsenal. So if you think it's been stupid so far, well, it's downhill from here. See you next time.